Hi everyone, my name is Alyaa Najwa and I'll be the first person to guide you through our integrated design project in the production of isopropyl alcohol.
For the relation of principle of chemical engineering, it is important to note on the calculation of mass balance and energy balance to ensure a reliable flow of the isopropyl alcohol production. Calculation of mass balance is needed to determine the amount of IPA produced from each process unit, while energy balance is used to calculate the heat of reaction of IPA production. Process flow diagram. A process called direct hydration of high-purity propylene and water with a solid catalyst is used for our production of isopropyl alcohol. Firstly, both of the reactants is heated to 246 Celsius and pressurized to 200 atm before entering the reactor in order to be mixed in a liquid phase. The propylene and water is then mixed in the mixing reactor with 80% efficiency of conversion to produce isopropyl alcohol. The unreacted components of isopropyl alcohol produced then leaves the reactor. Next, before entering the separator, all the substances are cooled down to 40 Celsius. Inside the separator, 90% of propylene is removed from the mixture in vapor phase. Since its density is the lowest, the gas can be easily separated, leaving the top column to waste. The mixtures that leave the bottom column contains IPA, water, and the remaining propylene gas to be sent to distillation column. First distillation column, which is set to 80 Celsius, focuses on removing remaining propylene gas, and since it has the lowest boiling points, the substance leaves the top column while the rest leaves the bottom column for further separation process. The second distillation column, which is set to 90 Celsius, removes water from our desired product, isopropyl alcohol. Since IPA has the lowest boiling point in the column, the product evaporates to the top column and leaves the column to be cooled down in the condenser before entering the storage tank. Meanwhile, the water remains, leaves the bottom column to the waste. The isopropyl alcohol in the tank now remains as liquid.
So, I am Laila Qistina will continue the presentation. Now, let's talk about the calculation for the reactive system, which is a mixing reactor. Firstly, we assume that the feed for both reactants, which is propylene and water, to be same, which is 50 kmol per hour each, and the product of the mixing reactor is propylene, water, and isopropyl alcohol. In this case, the efficiency of conversion is 80% for production of isopropyl alcohol, which means only 80% in the feed will be reacted. So, we use stoichiometric coefficient to calculate the molar flow rate for each component in and out. After doing the calculation, we can use the formula in plus generated equals to out plus consumed to prove that our calculation is balanced. Now, moving on to the calculation of energy balance, the pressure is set to 200 atm inside the mixing reactor to liquefy the propylene gas. The reaction takes place in a liquid phase for propylene and water. The temperature inside the mixing reactor is set to 250 Celsius degree and the temperature at the feed is 246 Celsius degree. Next, we set the reference state at 246 Celsius degree, the pressure is 200 atm and it is at liquid state. We use this formula for the calculation of the open system. And by using the first method of calculation, which is heat of reaction, we got the heat transferred to the system is 4548.401 kJ per mole. Let's move on to the non-reactive system. We assume that the feed flow rate is 60 kmol per hour and it contains propylene, water, and isopropyl alcohol. At the top product, there is only propylene, while at the bottom product, it also contains propylene, water, and isopropyl alcohol. These are the physical properties of all the components that we consider during the calculation. First, we calculate the molar flow rate of the bottom product and top product using the equation in equals to out. We also calculate the mass flow rate by multiplying the molar mass with the molar flow rate. We construct a table so that we can do the calculation easily and substitute all of the values that we got just now. As for the energy balance, based on the reference, we put the temperature of the feed to be 40 Celsius degree at 1 atm. For the top and bottom product, we put the temperature 80 Celsius degree at 1 atm. We construct a table so that we can do the calculation easily and substitute all of the values that we got just now. This is the reference state of each component to calculate the energy balance. Here is the working steps of the calculation. And lastly, using the formula there, the value of the heat transferred is 67,486.077 kJ per hour. So this is the in and out table for the energy balance calculation.
I am Mohamad Zafran and I will talk about transportation strategy of the main product. So we have 6 factors of it. The first one is pipe transport, second tank construction, grounding system, pump selection, storage tank specification, and last but not least, safety. So this is the summary of our storage tank specification. Next, we calculate the pump power. At first, we calculate the velocity from weight flow rate. Second, we calculate the Reynolds number and the fanning friction factor F. Third, we got total friction loss. Then we can get the work done from Bernoulli equation. Finally, we can determine actual work from the 70% efficiency. For the type of tank, we used internal floating roof tank. The advantage is it is suitable to handle volatile liquid. Then it can minimize evaporation rate. Also, it can reduce pollution of isopropyl alcohol. Then, for pipe transport, we use an insulated 4-inch diameter Schedule 50 stainless steel pipe. This pipe length allows for heat dissipation so that isopropyl alcohol can reach the desired temperature before entering the storage tank. The other strategy for the pump selection, we use centrifugal pump with 70% of efficiency. It is ideal for lifting isopropyl alcohol to the top of the tank. The advantage is the centrifugal pump is ideal for this task because it effectively handles low viscosity liquid like isopropyl alcohol. This type of pump will elevate the isopropyl alcohol smoothly, ensuring proper flow into the tank. Then, other safety aspect that we put in our plant is nitrogen blanketing. It maintains a low oxygen environment inside the tank. It can prevent contamination and peroxide formation in anhydrous isopropyl alcohol exposed to air.
Tank construction. Stainless steel, particularly 316L grade, is crucial for tank construction to prevent corrosion from IPA exposure. Next, grounding and bonding. To dissipate static build-up, connect the tank to a reliable earth ground to allow safe discharge of static charges. Ensure electrical continuity and by bonding and grounding, earthing, all equipment.
I am Vinoshen and I will be explaining about the fluid mechanics section of our project. Fluid mechanics is crucial for isopropyl alcohol synthesis through direct hydration. It shapes the reactor system, helping efficient mixing and heat distribution. Different reactor types are chosen based on the duration and flow patterns. It impacts the mass and heat transport, enhancing reaction rates and yield. Fluid mechanics affects the distribution of reactants and products, influencing reaction kinetics and product quality. Managing flow rates, pressure, and mixing is vital for scaling up production smoothly. Fluid mechanics also contributes to safety by preventing turbulence and cavitation. Overall, it optimizes efficiency, consistency, and safety in the manufacturing process. These are some of the important details regarding this project. The type of pipe we use is Schedule 40 commercial steel pipe because it has high resistance towards corrosion and temperature, and it can be recycled. The pipe has nominal size of 12 inches for the diameter to allow a high volume flow of the isopropyl alcohol. We use two main fittings which are the 90-degree standard elbow and globe valve throughout the system. As for the pipe length, we have chosen a reasonable length so that we could reduce friction as much as possible and prevent wastage. For the main section of the fluid mechanics of this integrated project, the pressure drop throughout the system. So these are the pipelines that we have chosen, from 1 to pipe 9. As you can see, we have also provided the pressure drops. So how did we calculate this? To calculate the pressure drop, first we need to find the velocity if it is not provided. Next, we need to find the Reynolds number. Then we need to find the friction factor. The formula used for the friction factor depends on the RE value obtained. Next, we find the total friction loss where we need to consider the number of fittings and their respective values of KE and KC. Finally, we find the pressure drop using Bernoulli's equation. We can simplify this equation. V can be cancelled due to the same type and diameter across the pipe. The Z or the height can be cancelled if there are no elevations present. The pump and turbine both can be cancelled if they are not involved in the pipeline, and that's how you get the pressure drop. What can be concluded from this integrated project? Firstly, we as a team got to deepen our understanding on fluid mechanics and principles of chemical engineering, as we had to find multiple sources and learn in order to make this project a success. Secondly, our isopropyl production plant has a good safety measurement to ensure the final product is delivered safely and especially ensuring the safety of the workers. Next, this plant is cost efficient. As previously mentioned, we found ways to reduce the cost. For example, we reduce unnecessary waste of pipeline lengths. Finally, we use high quality materials in order to satisfy public and all corporate needs for isopropyl alcohol, but most importantly for the efficiency and quality of isopropyl produce. Thank you.